Bismillahirrahmanirrahim, and welcome everyone to our 11th session in the Project Management Professional course. And we're still discussing planning in the project. And again, since planning is probably the most important thing that the project manager should be focusing on, then that's why we're taking so long in planning. You will see after we finish planning, I think we need only two lectures to finish the course. So most of the course is based on planning, especially that every and all project management terminology is also explained in planning. So what we did so far when we started the planning for the project is that we started developing the subsidiary baselines, subsidiary project management plans and baselines, as we mentioned, right? So we started by developing a stakeholder engagement plan, then a scope management plan and a scope baseline, then a schedule management plan and a project schedule baseline, and then a resource management plan, basically to identify the physical and human resources that we need to do the activities that have been outlined in the schedule, in the project schedule. And in the last session, we also explained how to develop a cost management plan and a cost baseline, as well as the project budget, which accounts for two types of reserves, right? The contingency reserve and the management reserve, okay? And then we started, or we actually wanted to start discussing planning for quality. And of course, as you know, scope, schedule, cost, and quality are the core constraints of any project. And for that reason, it's very important to have a plan for them in every project. So now to the fourth core constraint of the project, which is the quality. And we started discussing the basics of quality. What is the quality definition? What are some terms in quality, standards, regulations, de facto, and so on. And then we started explaining a very important principle of quality, which is the cost of quality. And we explained that the cost of quality is basically two things. Cost of conformance, which is the cost or the money that we spent in the project to avoid failures. And this includes the prevention costs. So basically, all the measures that I can use in order to try to prevent any errors from taking place, such as training, documenting processes, equipment, good equipment, and time to do it right. And appraisal costs, which are the costs that we pay to assess the quality of the product or the products of the project. So we basically need to do testing, maybe in other scenarios, destructive testing plus, and inspections. This is the cost of conformance. This is the cost that companies that are focusing on achieving quality will pay, the cost of conformance. While there is also the cost of non-conformance, the money we spend or the money spent during and after the project because of failures. When you don't pay attention to quality, when you're not concerned with the quality, you end up paying the following two types. Internal failure cost, which is we pay when we discover defects before shipping the products to the customer. And in this scenario, we need to rework those products or scrap them. And the worst cost is basically paid when you ship faulty products to the customer and the customer discovers the defects. Then you end up paying for liabilities, warranty work, and you might lose your business with this customer because of the low quality of your products. And this is the cost of non-conformance. And we explained that the cost of non-conformance is much higher, obviously, than the cost of conformance. Correct? Okay, let's continue then to other basic quality methods and theories that you also need to know as a project manager. We have the following approaches named after certain scholars in quality. The first approach which is named after W. Edwards Deming. It's a popular approach. Deming is one of the probably the most famous quality scholars who participated in developing quality approaches and how to improve the quality on all levels. So basically, Deming invented or introduced the Deming cycle, or what we call the PDCA cycle, that focuses on continuous process improvement, where we can focus on improving the quality continuously by this simple cycle, which is plan, do, check, and act. So basically, you plan for how to improve the quality of the product or the process. So you put together a plan, and then you execute your plan, you do it, and then you check the results of this plan, whether you have met your objectives or not. And then you act on those results and think how you can improve those results as well, and what went wrong and what went well. And then you go again and create a new plan. And then you continue following this cycle. And as we mentioned, you try all the time to improve the quality. Now, this is an important, actually, principle in quality. You don't have a ceiling for quality. You can always work on improving the quality. There is no limit for improving the quality. And for that reason, in many approaches, as well as Deming, you have this kind of continuous improvement cycle where you all the time find ways to improve the product or the process or even the people and the interaction among the people and so on. Okay, so there is no limit, there is no ceiling for improving quality. And this is basically the Deming cycle, or the Deming's wheel, or the PDCA cycle. Okay, so this is the approach of Deming. Another scholar, which is Joseph Juran, which is also a very known quality scientist or scholar. Juran trilogy breaks quality management into three things. Quality planning. So you need to start by planning for quality right from the beginning of the project, of developing the product. You need to plan for quality. So what is the quality that you want to embed in your product, for instance? So what are the quality metrics that you need to measure in the product? So first, planning, and then quality control, which is basically inspection, testing, and trying to find ways to improve. So improvement. So again, it's a similar principle of what Deming has introduced, but focusing on three, or in a trilogy, which is planning, control, and improvement. And Juran is also known for a very important principle in quality, which is the 80-20 rule. You might have heard of the 80-20 rule, right? So basically, Juran tells you that 80% of the issues that you are facing in your product, in your working environment, is caused by 20% of probably the bad practice that you are doing or the mistakes that you are doing. So 20% of the mistakes that we are committing in the working environment in the project, only 20% of them actually are causing 80% of the problems that we are suffering. Okay, so basically by finding those 20% and by eliminating those 20% of the mistakes that you are committing in your product, in your working environment, you get rid of 80% of the issues and the problems that you are suffering. Okay, and this is actually a popular concept. It doesn't even, it's not only applicable in equality, it's also applicable in so many things. And Pareto also is an Italian scientist, also talked about it, Pareto, and that's why we also call it the Pareto principle, and has observed that this principle applies actually in so many things. For instance, in sales, 80% of the revenue come from 20% of the customer. In economy, 80% of the world economy is concentrated in 20% of the countries, and so on. So basically, it's a general principle, and it has another reason for another name for that reason. We call it also the trivial many and important few. So basically, there is only few important factors, 20% only, but those are the important factors that are causing you 80% of your issues. Why the other 80% of the factors are trivial. They're not actually contributing to, they contribute only to 20% of the problems that you are suffering. So again, by identifying those 20%, which are the important few, and getting rid or correcting those 20% of those factors, then you end up eliminating 80% of the defects or issues or problems that you are having in your products. Okay, and this is also applicable to your, even to your personal life. You know, you are probably, or we are probably making only few, you know, mistakes in our personal lives. Probably someone is smoking. This bad habit, which is smoking, is or will be probably responsible for many bad symptoms, illnesses that the person might have just because of smoking. If he only quits smoking, his health, his lifestyle will probably improve by 80%. It's only one bad habit. Okay, he might be doing, or she might be doing, a lot of other bad habits, right? But getting rid only from this one bad habit will improve 60%, 70% of their health or of their lifestyle. Exercising, for instance, is another example. You need only to, you know, probably to quit smoking and start exercising, and you will improve 80% of your lifestyle, right, and of your health. So this principle actually applies in so many things, as I mentioned. And inequality, Juran has indicated, and Juran has introduced this principle into quality. So 20% or 80% of the problems that you are suffering are caused by 20% of the factors or the causes that or the mistakes that we are doing in the project or in the working environment. Okay. Another important principle in quality is introduced by Philip Crosby, which is again a quality scientist. Crosby is known for the principle of prevention over inspection. So basically, Crosby tells you that we need to focus on prevention rather than inspection, right? So when you focus on prevention, prevention would basically cost you a lot less than inspection, and it will save you as well a lot of money that you might need to invest in inspection. So when you focus on prevention, you save a lot of the money dedicated to inspection. So better to focus on prevention rather than inspection, okay? And in quality terms, prevention is basically what is referred to when we discuss quality assurance. So how do you prevent errors from taking place or issues in quality? By doing quality assurance, by taking measures, as we mentioned earlier, by taking all measures that would help you in preventing those issues, like training your employees, like documenting processes, like using good equipment, and so on. So all of these are considered quality assurance. While inspection, testing, destructive testing loss, as we mentioned, is what we do under quality control. Okay, so quality assurance is basically more important than quality control. If you focus on quality assurance, you reduce the need to quality control. And it's less expensive, of course, to focus on quality assurance, right? So again, if you quit smoking, then you don't need to go every week to the doctor and make a checkup for your chest, okay? So because what? Because you focused on preventing the problem from occurring by quitting bad habits, by starting exercising. So when you do this, you don't, or you reduce basically a lot the need for inspection. You don't need to go to visit the doctor every day or every week, right? So prevention over inspection, or as well, Crosby mentioned the zero defect principle. Zero defect. By focusing on prevention over inspection, you try to start right and do it right from the first time. So you have zero defect, because defects are costly. If you discover a defect, then again, you need to rework it or scrap it. And this costs a lot, okay? But focusing on prevention will help you achieve zero defect, okay? And this is the principle of Crosby. So you have here Deming, okay, and the Deming cycle. You have here Juran, the 80-20 rule. And you have here Crosby, zero defect or prevention over inspection principle, okay? Those are probably the most important principles in quality. Now we have also other approaches like Genichi Taguchi. Taguchi is a Japanese, of course, scientist. And the method emphasizes that quality should be designed into the product, planned and designed into the product. So factors can cause variation, can be identified and controlled. So basically, I want to identify those factors that might cause this variation that we need to eliminate. Variation is always something that is not desirable. We want every product to be exactly a copy of every other product that satisfies quality requirements. So if you have this variation, and you will have this variation for sure, but we need to try to minimize this variation. And Genichi Taguchi suggests that by designing quality in the product, and by defining those factors that will be responsible for variation, and by measuring those factors all the time, we can improve the quality of the product. Another approach, which is William Bill Smith. William Bill Smith has introduced the Six Sigma approach, which emphasizes on, again, on continuous improvement by responding to customer needs and improving processes systematically. And this is done also by another cycle, which we call the DMIC cycle. Basically, one of the also very important principles in quality and in management as a whole is a principle that tells you that you cannot manage and improve what you cannot measure. So if you want to improve anything or manage anything correctly, you need to measure it. You need to find a way to measure it. If you cannot measure it, you cannot improve it. You cannot manage it, and you cannot improve it. And this is what Six Sigma relies on. Six Sigma is introduced also by Motorola, the known company, telecom company, uses an improvement cycle that we call the DMIC cycle, which stands for define, measure, analyze, improve, control. So basically, you use this systematic approach to improve processes over time and to reduce or eliminate the variations again of the process. So you start by defining what is the current variation of the process and measuring it and defining the target. What do you want to set this variation to? And then you analyze how you can do this. How can you optimize, or how can you better the process? So you analyze what are the factors that contribute to this variation. And then you improve the process based on the analysis results that you have done here. And then you control and stabilize this improvement so you can maintain this level of improvement. And then you set a new target of improvement. You define a new target for improvement, and then you continue on following this process. And by doing this, Six Sigma tells you that you can reach the level of Six Sigma. Basically, Sigma is a standard deviation in statistics. Sigma stands for, or another expression for, the standard deviation in the statistics science. And basically, when you improve the process following this systematic approach, you can reach to the sixth level of Sigma, or the sixth standard deviation. And when you reach this level, you will have only 3.4 defects per million. So if the process takes place million times, if we repeat the process million times, you will have defects only in 3.4 of the million time. You will have issues in the process, right? Of course, this is applicable only in certain industries like manufacturing, industrial, businesses. It's not applicable, for instance, in the service sector, because in the service sector you have lots of human inputs to the processes. But in the manufacturing industry, there is, you know, a minimum intervention from the humans, and for that you can basically you can calibrate and reduce and eliminate the variations by following this process. Okay, so these are basically the most important approaches that you need to know as a project manager, and you also can take into consideration when you think with your team on how to improve the quality in the project and the quality of the products that we are working to create, right? So again, a very important principle in that is a common principle in quality approaches, indicates that quality does not have a limit again to improve. You can always find ways to improve quality. Now, there are two ways to improve quality. There are two ways for continuous improvement. The Japanese way, which we call the Kaizen, which depends on small incremental improvements suggested by the workers themselves, suggested by the team themselves. So everyone from the team can suggest or introduce a small increment in the quality of the work or of the product. And this is very cheap, does not take time, does not take research centers, for instance. And it can happen all the time. So this is the Japanese school of improving, continuous improvement. Or you have the other school, the Western school, which depends on large breakthroughs of quality improvement by investing in research centers, dedicated research centers that spend years and years doing researches on how to improve the quality of the product or how to improve the quality of the work. And this, of course, costs a lot and takes time a lot, but they make, at the end of it, they make a breakthrough. They bring a completely different products or completely different processes that are completely different from the old way of working, right? So these are the two schools of continuous improvement. And the Institute of Quality, there's an American, Institute of Quality Assurance, defines continuous improvement as improving business strategy, business results, and customer, employee, and supplier relationships. So improving quality does not only focus on the product itself, it focuses on everything in the business. So basically, you improve the business strategy, you improve the business results, so basically the financial results of the business. You focus on improving the customer relationship, the employee relationship, the suppliers relationships, okay? So quality improvement is not only concerned by improving the quality of the product, no, quality in everything, as they mentioned, right? So basically, you need to focus on improving the quality of all of the aspects of the business, okay? Now, who is responsible for improving the quality of the project management that the project management practice in the organization? Who would be responsible for that? Of course, it's the PMO. If you have a PMO, the project management office, then the PMO is also responsible for improving the quality of how we manage projects, right? So because they should be supporting, right, as we mentioned, and controlling the way that we manage projects, and by this they are improving the quality of how we manage projects and improving the results, right, of the projects that we manage, okay? So again, Demings has 4 concepts of improving the quality. Improving the quality by better design of products to improve service, higher level of uniform product quality, improvement of products testing in workplace and research centers, and this will yield greater sales through global markets. Okay, so basically, Demings tells you that if you want to do more sales, if you want to penetrate a new market, if you want to sell to global markets, then of course you need to build quality in your products. You cannot sell products globally if you have bad products. But if you have good products, then you can sell the products to any country, right? To the global markets. So Deming's philosophy again was that improving quality would reduce expenses. So again, the cost of conformance, increase productivity, and even the morale of the people. The morale of your team will increase when you take care of the quality, and thus we will increase the market share locally and globally. Okay, and this is actually what everyone notices now, right? When you buy any product, when you think of buying a new car, a new mobile phone, you know, any product, printer, whatever you're thinking of buying, you look for quality products, right? You prefer, for instance, most of the people, of course, you prefer Japanese cars, Korean, I don't know, Korean mobile phones, for instance, right? Because for the reputation of the quality, right? So they have penetrated the global markets because of the quality of the products that they build, right? Now, how can we in the project improve quality? Improve the project management quality. Those are the tools that we use to continuously improve the quality in the project. You have lessons learned register, which is a document in which we compile and document the lessons learned in the project. So basically, whatever we did wrong, how to avoid it next time, or whatever we did right, how to increase on it, or if there are any things that we can improve, and next time when we do the job, then all of this is documented in the lessons learned register. So the lessons learned register is a document that we use to continuously improve quality in managing the project, okay? In Agile, we also mentioned the retrospectives, right? The retrospective, which is a meeting that is held at the end of the sprint, and where the team, basically with the product owner, discuss on how to improve the performance of the team and what went well and what went wrong, right? So this is again a tool of continuously improving the quality of the project. And we can also do experiments that would help us also improve the performance and the quality of the project management. So we can do, for instance, A/B testing. We try to do a test, a limited test on how to do things. Should we use this supplier or this supplier? We try to do a test, a small test. We give this supplier a little bit of work and we give this supplier a little bit of work, and then we compare results and identify who's the best supplier to work with, for instance. Okay, so basically those are the tools that you can use to continuously improve while you're managing your project. Okay, now let's explain some of the most important quality management tools that you might need to use as a project manager, of course, along with your team. We will discuss the quality assurance tools. So what are the tools that you can use in quality assurance? And again, quality assurance focuses on what? Focuses on prevention, not inspection. When we discuss quality assurance, then we're concerned with prevention, preventing errors from taking place. And we will discuss other tools that are used in quality control, such as control charts and variability, Pareto charts, statistical sampling, and how we do the statistical sampling process. So let's start with the quality assurance tools. These are some of the most important quality assurance tools. Of course, you need to start by gathering data all the time. So in order to figure out how to prevent errors from taking place, you need to gather data. You can do this by going back to previous projects again and checking some checklists of the, the things that went bad in previous projects. There are checklists, lessons learned again, and you can use those checklists in order to avoid the same mistakes in this project, as well as a list of acceptance criteria that have been identified. For instance, when we gathered requirements in the project, so these are the acceptance criteria that I need to focus on in order to prevent issues in quality. And then after gathering data, you need to analyze those data. You can analyze data by, again, looking at alternatives. So how can we do the job in a different way that minimizes the possibility of making mistakes or making errors? Document analysis. So we try to analyze any documents that will help us identify certain measures that we can take to prevent errors. Process analysis. We analyze the processes that we are using and check whether these processes are solid and there is no chance of making mistakes while using those or while following those processes. And we can also use a formal root cause analysis. If we identified some issue, some recurring issue, for instance, and we need to eliminate this issue completely, then you need to do a root cause analysis. I think that some of you probably have an idea about the root cause analysis. What is a root cause analysis and how we use a root cause analysis? This is how we use a root cause analysis, okay? We start first by drawing this line and writing the issue here. So for instance, I have, the issue is that I have a high number of defects. I discovered a high number of defects taking place in the project. The approach is what we call why. In order to find the root causes of the issue, you start asking why. In Toyota, they also call it the 5 whys approach, because you can ask up to 5 times why. Why is this issue happening? Why do we have a high number of defects? Of course, I would ask this question or discuss this question with the team and other stakeholders as well. So somebody would suggest that we are having a high number of defects because the equipment that we are using is not good, okay? Bad equipment. While other person, other stakeholder or other team member would suggest other thing. They would suggest that one of the reasons that we have a high number of defects is that the team is not performing well, so bad performance. This is the first why, right? And then we continue on. So why do we have bad equipment? Now, some stakeholders or some of the team members would suggest 2 things or 2 factors contributing to the bad equipment. One is that we did not do enough preventive maintenance to those equipment. So basically, when you don't do preventive maintenance to the equipment becomes, faulty, right? And the other thing that they are old equipment. So basically also when you use old equipment, you get bad results, right? So this is the second one. And then you continue on. Why we don't do enough maintenance? Then we try also to find the reason for what, or there might be, again, 2 reasons, 3 reasons for that. So someone would suggest we don't do enough maintenance because we don't have fund or money for that, fund for or budget for that, no budget, not enough budget to do maintenance. Or there is another reason, we don't have the expertise of doing preventive maintenance. Okay. Why do we have old equipment? Again, the reason might be the budget, might be the bureaucracy, might be the decision-making process in the organization, and so on, right? Might be many things. And the same approach will be followed again in the other, branch. So why do we have bad performance within the team? Because the team did not get enough training, because the team has low morale, for instance. And why does the team have low morale? Because there is no rewards and recognition system, because I don't know, there was problem with the labor association or whatever. Okay, so again, you ask why and you continue asking why until what? Until you find the root causes that you cannot ask why beyond, or that you know that there is no point of asking why more than that. Okay, why don't we have why there is no budget? You cannot ask beyond that, right? This is out of our control. But we have the root causes that if you eliminate them, now if you want to eliminate the high number of defects, you don't start working here or here or here or here. You start working and eliminating on what? You start eliminating the root causes. When you eliminate the root causes, this issue will disappear completely and forever. But if you cannot eliminate the root causes, this issue will continue to resurface every now and then. Okay, so for that reason, if you get a question, for example, in the exam, and they ask you, why is this problem still happening again and again and again? The reason is that we have not resolved this problem by resolving the root causes of it. So when you don't eliminate or resolve the root causes, this problem will continue to resurface every now and then. Okay, so this is what we call, this approach or this analysis is what we call the root cause analysis. And you get here a diagram that looks like what? It looks like a fishbone, right? So that's why we also call it the fishbone analysis. We call it also Ishikawa analysis for the Japanese, again, scientists that worked on it. And we also call it as well cause and effect analysis, because basically you are connecting causes with effects. Okay, so all of these terms basically point to the same analysis, which is, again, why, or sometimes we use a different approach, which is how did this happen? So how and how and how until you figure out how did you have this issue, by asking how and how again. Okay, so basically this is the root cause analysis. You need to take decisions in order to again to prevent issues from happening. So you need to basically to use some decision-making techniques like voting or voting by majority or unanimity. You might need to represent the data that you have gathered and analyzed. So you might want to present them in affinity diagrams, in cause and effect diagrams, as we seen, in flow charts. I'm sure you've seen flow charts. Flow charts, again, are charts that we use to analyze a process. So basically, if I have a process and I have a problem with the process, I can present the process by a flow chart. So what are the steps that we are following in this process? Now, usually the flow chart would look something like that, where you have the steps, you know. So you start from here, for instance, and from here you go to here, and this is the next step. So the third step, the fourth step is basically you have two options, yes or no. So based on a test that you make, for instance, or the decision that you make, the process continues, okay, and so on. So this is a flow chart. So if you have you are facing an issue with the process, you basically develop this flow chart for the process, and then you try to figure out where is the fault taking place, where is the issue is happening. Is it in this step or in this step or on this step? How can we eliminate this from happening? By analyzing the flow chart of the process, okay? So this is again a diagramming method that you use to prevent, to check and to prevent, of course, issues from happening. Flow charts. Histograms is another representation of the data that you might gather. Histograms have this shape. Basically, especially if you are measuring something, then you might want to represent or present the results by a histogram. The histogram would look like that. So you have here the results of measuring, for instance, the width or the height of something in your product. And then you set the results, you measure the results, and you represent them on this histogram. And the benefit here from the histogram is the easy of comparison, right? Now you know very quickly, you can identify the, you know, the largest measure, the lowest measure, probably also the mean or the average, something that looks like here, okay? So this is what we call a histogram. Matrix diagrams, so you can use matrices or tables in order to compare different things. Scatter diagrams as well. Scatter diagrams, you also probably use them in the university. Scatter diagram looks like that. You try basically to figure out or to find out the relationship between two variables. For instance, the temperature and the humidity. Is there a relationship between the temperature in the weather and the humidity? So you start doing experiments, right? So you try to figure out when the temperature was, for instance, 10, how was the humidity? 80%. So we increase then the temperature. Let's test when the temperature is 20. The humidity is 60%, for instance. And then we increase the temperature and so on. So basically you get this scatter diagram. This is what we call a scatter diagram. And by connecting the dots, you try to figure out what's the relationship between the humidity level and the temperature in the weather. Okay, so this is a scatter diagram. Again, it's a way of representing the data that you are gathering and that you are analyzing in your project. Okay. Audit is one important tool for quality assurance. I want you to keep this in mind, especially when you get this in the exam. You will get for sure questions in the exam about audit. Whenever you hear the term audit, it means quality assurance. This is number one. Number two, whenever you hear the term audit, it means inspection for processes, not for the product. When we do audit, we audit the process. Are we following the right processes? Are the processes efficient, effective? Are the processes working well? Okay, is the team following the right processes? So audit is always about the processes, not the product, okay? While inspection, on the other hand, inspection and testing is focused on the product, okay? So of course we need to do audits every now and then in the project, and we need to make sure that the team is following the right processes, and the processes are efficient, or probably the processes need to be re-engineered. We need to improve our processes. So these are the results that we need to get and to put in the audit reports. So what is going well, what is going bad, how to improve the processes, how to improve the following of the processes among the team, and so on. Okay. Another tool is design for X. You review the design of the product several times, and in every time you review the design for X, which stands for many things, right? So basically you review the design, for instance, for performance. Is this a good design for performance? And then you review the design for security. Is this design good for security? For stability, for user friendliness, for, you get the point? So basically you review the design several times, and every time you check whether this design fits certain important criteria in the product. Okay, and this is again is considered a prevention tool, because you want to create a design that fits all the important criteria in the project, right? You also might want to do some problem solving, so you use problem solving techniques, and as well as other quality management approaches that we have mentioned, such as the Six Sigma, the plan, do, check out, check, act cycle, and so on. So these are the most important quality assurance tools that you might want to use in the project. As for the quality control tools that we use for inspection, especially, you have the following tools that are important for inspection. The first tool is the control chart that we use to measure the variability of a process. So if we have a process, for instance, to fill in the cans, the Pepsi cans, okay, so there is a process that the team is following in order to fill the cans, and you need to make sure that this process is working well. Basically, you need to make sure that the results of this process are accepted. And how do I represent that? Is by setting the mean or the target. So for instance, the target here is that every Pepsi can will be filled in with 330 cubic millimeters, right? This is what we all expect, right, in a Pepsi can. A Pepsi can should be filled in with 330 cubic milliliters of the Pepsi, right? But of course, this will not be accurate all the time, right? But there is certain limit that is, or tolerance, where we accept the amount, right? We have an upper control limit. Okay, so this represents the upper control limit. So basically the industry or the regulatory or the law imposes an upper control limit. You are allowed to have up to, for instance, 335 cubic millimeter. Okay, this is the upper control limit, and beyond that, like the point A, is considered what? Is considered not acceptable, right? The process went out of control at this point. And you have also a lower control limit. Let's say, for instance, the standard in the industry, or again the regulatory, allows for until 325 cubic millimeter. Okay, so this is the lower control limit. Now what you do is when you are following the process and filling in the cans, you take samples, right? And you measure how much we have in those samples. So basically, if you get the result here, now, like 328 or 329, is it accepted? Yes, it's accepted because it's within the limits, right? Correct? This accepted. This here, if you have the result here, if you measure the amount of fluid and you find it here, it's accepted. Here is accepted. What if I get the result here on the lower control limit? Now you might get this question in the exam, right? They might give you, you know, this diagram and tells you what is accepted, what is not accepted. Now, if it is on the limit, like for instance here or here, it's not accepted. Okay, it should be within the limits, not on the limits. Take care. This is number one. Number two, in certain situations, like here, you get these points. 1, 2, 3, 4, 5, 6, 7. Are all of those points or samples accepted? Yes or no? Are they accepted? They are accepted because they are within the limits, right? We haven't gone beyond the limit like here or here or here. No, all of them are within the limit. But there's a concern here. What is the concern here? We have 1, 2, 3, 4, 5, 6, 7 consecutive points above the mean, right? And this is not normal. Yes, on one side of the mean, whether it's above or whether it's even below, like in the next shape, 7 below the mean. This indicates a problem. This indicates a special source of variance, we call it. We call it also an assignable cause. It indicates an issue. Why it indicates an issue? Why do you think it indicates an issue? Because in the nature, we have something that we call the normal distribution, the normal probability distribution. For instance, when you throw a metal currency, you know, you get either head or tail, right? So when you throw it, for the first time, maybe you get heads, the second time tails, and then 2 times heads and 2 times tails, and so on. But if you throw the currency 7 consecutive times, and in every time you get the heads, then this means what? This is against the normal probability distribution. It means that this currency has an issue, right? It's not a normal currency. Someone is cheating, right? And this is what's happening here. 7 consecutive samples on one side, whether up or down, on one side of the mean, it means higher or lower, 7 consecutive samples. It means there's an assignable cause. There is a special source of variation. We have an issue. The 8th or the 9th point will be beyond the limit. And we need to start investigating. There's an issue. Even if all of the points are accepted, but again, this is against the normal probability distribution. Okay? We call this what? We call this the rule of the 7. This is called the rule of the 7. So what's the rule of the 7? The rule of the 7 indicates that if you get 7 consecutive points on one side of the mean, then this indicates what? An assignable cause or a special source of variation that we need to investigate. Something is not going well. Okay, you might get an exam, such a scenario where they ask you, where would be the 7th point in order to have an assignable cause? Here, for instance, or here, or here, or here. Because the 7th point should be here. This is the 7th point now. 1, 2, 3, 4, 5, 6, 7. So this is the 7th point that if I get the result here, then I will have an assignable cause. Okay, does that make sense? Are you following? Okay, so this is the control chart that we use to indicate the variability of the process and whether the process is in control or out of control. So again, if you get 7 consecutive points below the mean or above the mean, this means that you have an assignable cause that you need to investigate. Okay. Another quality control chart or tool that you can use is the Pareto chart. And we mentioned the Pareto, right? The 80-20 rule. So basically, we mentioned that we need to identify those 20%, those important few that are causing us the majority of the problem, the 80%, right? How do we identify those 20%? By using a Pareto chart, which is a histogram again. So basically, we ask, for instance, the people. This is a scenario where we want to investigate the problems or the issues in a restaurant. So we prepare a survey and we ask the people, what are the things that you don't like in our restaurant? And we represent those results on a histogram. So we get those results. For instance, 50% of the people believe that the restaurant is overpriced. 40% believe that the food comes in small portions. Around 35% believe that the restaurant is noisy. Around 15% think that the food is not fresh. Around 5% think that the table were not clean. Okay, so when you represent the results in a histogram, then you know or you identify the 20%. Where are the 20% now? This and this, right? You have 2 things to resolve in your restaurant. In order to get increase in satisfaction by 80%, you need only to work on resolving 2 things. You probably need to lower your prices and increase the portions of the food. When you do this, when you do only those 2 things, you increase that satisfaction by 90%, because the majority of the complaints focus on those 2 things, right? 50% and 40%, right? So this is a Pareto chart that helps you identify the important factors, the few important factors that contribute to the majority of the complaints, okay, or the issues that you are having. Last but not least of the quality control tools is statistical sampling. Now, you use statistical sampling when you cannot inspect all the products. You have a very large number of products, probably hundreds or thousands, like we mentioned, the Pepsi cans. You cannot test and inspect all the Pepsi cans, right? Or you are producing, for instance, computer chips. You produce computer chips probably in millions. You cannot inspect all of the computer chips. So what you do is you do statistical sampling. You take samples, right? According to certain statistical rules, you take samples and you inspect them in order to make sure that quality is achieved. Now, there are 2 ways of inspecting, of statistical sampling inspecting, which is the attribute sampling data where we ask the inspectors to focus on certain attributes like the color, the shape, you know. So basically it's either yes or no, it fits or it doesn't fit. Okay, you have no other option, either it's yes or no. Or we ask the inspectors to do some measurements, so it's called variable sampling data. So you need to measure the voltage between, you know, those, I don't know, two legs in the chip, and check that the voltage is within the range, the acceptable range. Okay, so this is variable sampling data, or like what we did in the Pepsi cans, right? We are measuring, so we are getting some variables, right? So you can do this and this, attribute sampling data or variable sampling data, and based on the results and analysis of the results, you decide either the quality is being achieved or not. If not, of course, you need to take corrective action. You get to know the trend. So the trend is the quality is improving or the quality is declining, for instance. And by doing this, you try to reduce the defects that that are happening in the project. Okay. And by doing this, and after you have now all of the information that you need to develop your project management plan. So we develop the project management plan, and these are the usual contents of the project of the quality management plan. So basically the quality management plan describes, again, what any management plan describes, the who and how, right? So basically, what are the resources and activities needed for the project team to achieve necessary quality objectives? What are the expectations and quality requirements that we need to meet in the project? Quality requirements might include standards, objectives of the project, roles and responsibilities. So who's responsible for quality assurance from the team? Who's responsible for quality control in the team, right? Project deliverables and processes subject to quality review. So what is the review that I'll be doing? What's the audit that we will be doing in the project or throughout the project life cycle? Quality control and quality management activities planned for the project. Quality tools that will be used. So what are the tools that we will use for quality assurance, for instance? And what are the quality tools that you will use for quality control? Will you use control chart? Will you use root cause analysis? Will you use audits? Will you use design for X? Okay, so you select again your tools that you need to use in your project, tailoring again, okay? And major procedures relevant for dealing with non-conformance. If you discover a non-conformance, then how do you go about those non-conformances? What are the corrective actions, procedures, and the continuous improvement procedures? So all of these can be included in the quality management plan. And by this, we conclude planning for quality. Now for agile considerations, like I mentioned, agile approaches use or prefer using the Kaizen principle, which is many small changes or improvements, not breakthrough improvements, okay? Because they don't require major expenditure or capital. The improvement ideas come from the workers themselves, from the team themselves. I don't have to, to hire experts, for instance. All employees should continually improve their own performance, and all are encouraged to take ownership of their work to improve motivation. Okay, so agile approaches focuses on using the Kaizen principle of continuous improvement, while predictive approaches tend to use the Deming cycle or the plan, do, check, act cycle. Okay, any question, ladies and gentlemen? Great, let's stop for 15 minutes and continue after that. See you in 15 minutes. Welcome back, everyone, and we concluded explaining the quality management plan and planning for quality in the project with the different tools that you might use for quality assurance and quality control. Let's move on now to another plan which is equally important, which is the communication management plan, to plan the communication in the project and who should know what, when, and by which means. This is basically my preferred description of the project management plan. The project management plan describes who should know what, when, and by which means. Okay, so we will be discussing the project communications and the communication management plan. Let's start by discussing the project communications. So communications can be internal within the team or external with external stakeholders like the suppliers, like the end users, like the customers. Communications can be formal or informal. So basically formal, documented, can be referred to, can be used as a reference. So those are formal communication, or informal communication, which are not documented or recorded or cannot be used as reference. Communications can be hierarchical, coming from the top management, for instance, or the senior management down, or can be also on the peers level. Communications as well can be official or unofficial. Official, it means declared for everyone and announced, while unofficial, it means it's kept for our internal use and not declared officially. Like officials, like annual reports, for instance, or reports to other governing bodies, they're official because you're declaring your status, okay? Compared to project team communications, which are not declared or which are unofficial, okay? Communications can be written or oral, verbal, spoken, can also include gestures, for instance, body language. So all of these can be also included in the communication. So basically we have these 4 types of communication. You have the verbal formal type of communication. It's verbal and formal, such as the presentations that we might to present to the management, for instance, the project reviews, the briefings that we do, the product demos in the sprint review, for instance, the brainstorming that we do when we discuss, for instance, the requirements of the product or the requirements for the project. So this is verbal, but verbal formal. And the other type is written formal, like the progress reports that we prepare for the management, like the project documents that we use, all the documents and artifacts that we use, like the business case as well, okay? And you have verbal informal, and basically most of the verbal is basically informal. It's very difficult to, to consider verbal formal communication. So presentations, because again, you cannot refer back to them. It's very difficult. Okay, so maybe we forget who or what did we say in the presentation, or how was the discussion, or what kind of the brainstorming results that we have come up with, and so on. Okay, so basically verbal is most of the time is informal, the conversations, the ad hoc discussions. And we have informal written, yes, such as the brief notes, such as the emails. Yes, emails are considered informal. Of course, unless there is a policy in the company that indicates that emails are formal. Okay, but as a general rule, emails are also considered informal, written informal. For instance, you cannot use them in a lawsuit. If you want to, to bring an evidence to the court, you cannot bring an email. They will not accept an email as an evidence, because it can easily, forged, okay, or falsified. So for that reason, unless, again, the email has some kind of digital signature, which proves that this email was issued by that person, okay? Instant messaging, of course, WhatsApp, text, all kind of, instant messaging is considered also informal. Social media is considered as well informal. And you have the written formal communication, which is, of course, the most important communication in the project. Like, again, we mentioned them, the progress reports, the project documents, and the business case. All the documents, basically the artifacts that you use and the management plans that you use in the project. So these are the 4 types of communications. Yes, I think even in the UAE, they accept it as well. Even in Bahrain, I think they accept it because they have this, encryption, end-to-end encryption that proves that, who's the sender and who's the receiver. Okay, but again, unless you have this specific and formal acceptance by, by the law, then otherwise it's not considered formal. Okay. Okay, communication types. Of course, we prefer all the time face-to-face meetings, but we have other communication types like video and voice, video conferencing, emails, faxes, instant messaging, text messaging, print media and documents, social media, company website. All of these are different media that you can use to communicate with other stakeholders. Now, this is the communication, the general communication model. This is what takes place basically when a sender sends a message to the receiver. So the sender has a message. The sender encodes the message in a way. Encodes, it means here encapsulates as well, the message in a way that the receiver can decode, and then sends the message on the communication channel, on the medium. So when the message is sent, it might be subject to noise. If I'm talking to you right now, the media is the internet, right? And I am encoding my message using the Arabic language, right? And of course, when the message or when the message is sent over the communication channel, which is the internet, it gets another encoding, level of encoding, which is, electrical encoding, until it reaches you on the other side where you're sitting. So basically, you decode, your devices will decode the message, and you can hear my voice and understand the letters, the Arabic language. So basically, you decode the message and you understand it. And then you probably do an acknowledgement. So when I ask you, everything is well, you can hear me well, you can see me well, you do this acknowledgement that you got the message. Again, there might be some noise. If I'm talking here and there are lots of noise here, you might not hear me well. So I need to make sure that you receive the message, and that's why I might ask for acknowledgement. And then when you want to give me some sort of feedback or response, then we switch places, right? The receiver becomes a sender and the sender becomes a receiver. So receiver encode their message and the sender decode the message. Okay. Minutes of meetings, yes, can be accepted if they are formal, because some of minutes of meetings are not formal. We just write them and no one signs them, and they're not, stamped or something. They are not formal. But if the minutes of meetings are documented and signed and I don't know, maybe stamped by the company representatives, then they are formal and they are accepted in the court. Okay. So sending and receiving. 2 things about the model that you need to pay attention to. First of all, again, when you send the message, you need to make sure that you are sending a message with an encoding that the receiver can decode. So for instance, if I'm talking now Chinese, probably you don't understand Chinese, right? You cannot decode my message, my words. Although you can hear them very well, but you cannot decode them. No, this is the first thing that you need to pay attention to, the encoding. The other thing is the noise, right? So if, again, if I have a lot of noise here, then probably you won't get the message correctly and you cannot understand it. And for that reason, it's a rule of thumb, it's a golden rule, that the sender should always ask for acknowledgement, right? Sometimes you get a question in the PEP exam, who's responsible for making sure that the message was delivered correctly? Is it the sender or the receiver? The answer is, who's responsible for that is the receiver, okay? Because if I am the receiver and if I doubt, if I think that I did not understand the message well, then I need to give this feedback, right? I need to ask the sender to resend, right? For that reason, you know, when talking over, for instance, over the walkie-talkie or over the, you know, like the police when they use their devices, they use the words "Roger that," you know, Roger that. It means I understand, I got your message and I understood it. Okay, Roger that. So this is a confirmation that you have received the message and you understood it. Okay, so it's the responsibility of the receiver to make sure that the message was received and understood. Okay, communication methods that we also can use in the project. Now, the best way of communication is, of course, the interactive communication. Two persons, for instance, talking face-to-face, exchanging information about the project, then this is an interactive communication. Sometimes for certain information, we use push communication, where one person sends the information to the other person without expecting a response from them. So basically, if every week I send a project progress report to my manager, this is a push communication. I'm sending the report without expecting an answer to it. Okay, this is a push communication. Or we can also use pull communication, where we basically put the information on a place that other persons can reach out to and take. For instance, we can put the reports on a shared folder in a server, and according to their privileges, other persons can access the shared folder and access those information. This is pull communication. So the people can reach out to the information and pull them. If you use a website, for instance, the company website is an example of pull communication, because you write the information of the company on the company website, and everyone who's interested in your company can pull this information, right? Can reach out to this information and can pull them. So this is a pull communication, okay? Now, again, the best way of communication is, of course, the interactive communication. Now, in order to develop a communication management plan, you start by analyzing the requirements. So the communication requirements analysis. Again, who should know what? So what are the information that we need to communicate? Who send, or who will be responsible for sending them? To who is concerned, or who has the interest of receiving them? And how this information will be sent, using which type of communication, for instance, or which medium for communication, which method of communication, and when or how often this information should be communicated. Okay, so we do this communication requirements analysis in order to identify basically what kind of communication we need in the project, such as interviews, workshops, study of lessons learned, and so on and so forth. And we basically also try to investigate how to make sure of clearly communicate with different stakeholders and meeting their communication needs or their information needs. and we decide on the best technologies that we can use. Of course, when you consider technology, you need to consider the cost of the technology, maybe also the time that you need in order to set up the technology. For instance, if we decide to use an email server, then this might need some time in order to set up the email server for the project team, right? As well the security, because maybe in certain projects, you know, military projects or research projects, you need a high level of security. So you select a secure technology for communicating and so on. So basically also need to select the technology, the right technology for communication. And then you might also need to develop other tools to communicate, like a questionnaire, surveys, and so on, and get to know everyone's expectations and needs of information. Okay. And by doing this, you can develop the communication management plan, which indicates again the stakeholder communication requirements. What are the information that need to be communicated, including the language, especially if we are working again with people coming from different cultures or different nationalities, then we need to agree on a common language. It's not recommended to have, you know, in the same project, some people communicating with Arabic and some people communicating in English and some people are communicating in French. No, we need to agree on a common language that everyone can use, okay? The reason for distributing those information can be indicated as well in the communication management plan, the time frame and frequency for distributing those information, the person or persons responsible for the communication, the person or persons responsible for the release of confidential information. If we have confidential information in the project, then I need to probably to identify certain persons who have the, you know, this privilege of releasing confidential information. The people who will receive, of course, the information, the methods or technologies that will be used, the time, again, and budget allocated for communication. So basically, when you develop your communication management plan, you might figure out that you need to update your schedule or update your project budget, right? Because you just found out that the technology that best fits your project needs some time or costs some extra money. So basically, you might want to get to your schedule and budget back and update them accordingly, okay? Escalation processes for issues that need visibility. So if we have issues, what is the escalation process? Methods for updating the communication management plan, glossary of common terminology. Sometimes in certain projects, we might use certain, you know, terminology that not every stakeholder understands. For that reason, we might want to develop a glossary of common terminology and distribute it to all stakeholders in the project so they can understand the terminology that we are using in communicating. Flow charts might also be developed of information flow, as well as any communication constraints due to regulations or policies. If there are certain constraints, you cannot communicate, for instance, with the customer directly. There might be a constraint, a policy in your company that does not allow you to communicate directly with the customer. You need to communicate with the customer, for instance, through the project sponsor. Then you need to follow those constraints as well. Okay, now this is an example of how a communication management plan would look like. So again, you have the stakeholders, you have the communication method, like meeting, kickoff meeting, extranet, intranet, executive steering committee meeting, status meeting, emails, newsletters, and so on. So the methods, the frequency, start of the project, ongoing, every Monday, weekly, Friday, 2 p.m., and so on. The responsibility, so who's responsible for this communication? I might also include the sender, the receiver, again, the language, and notes, okay? So this is a general template that you can tailor to your needs. Okay. As for Agile, as you know, and as we have discussed so many times, Agile prefer certain ways of communication. Agile, for instance, prefer face-to-face communication all the time, right? It's one of the principles of the 12 principles in Agile. Agile also prefers using low-tech, high-touch tools, such as information radiators, which are, signs that we actually put in a central place in the room, and they hold information, or they present information about the project and the project progress, the task boards, the flip charts. So again, Agile prefers simplicity, prefers low-tech, high-touch, high-visibility tools, and face-to-face communications. Of course, Agile have certain ceremonies or events or meetings that we usually follow, like the sprint planning meeting and the first day of the sprint, like the daily stand-up every day, like the sprint review at the last day of the sprint, and the sprint retrospective again at the last day of the sprint. So these are ceremonies that we follow usually in Agile. And again, those are face-to-face meetings, which makes the communication smoother. And all of the time, it's an interactive communication. Again, it's not push or pull, it's an interactive communication. And makes things, or makes the team communicates better and faster than traditional approaches. Remember also that we tend to use co-location or tight matrix, right? We tend to gather the team in one room so they can also communicate faster and more efficiently and interactively, of course. Okay, any questions so far? No question? Great. Let's move on now to another planning aspect, which is risk, or planning for risk. And of course, this is very important in the project. You need to make sure that you are planning for the risks in the project. So what are the project risks? And we will discuss the risk register, which is the main document that we use to document risks and their characteristics. How do we perform, and why do we perform qualitative risk analysis and quantitative risk analysis, and how we develop risk response plans. So let's start first by discussing the risk management approach. Now, every project has risks. This is definitely, the life is about taking risks, right? And there's a rule, you know, a general rule, that the higher risks that you take, the higher rewards that you might get. So if you take more risks, then the rewards will be higher. But if you take less risks, then the rewards will be smaller. Okay, so basically you need to make this, this proper balance between risks and rewards. And this depends, of course, on the stakeholders' risk tolerance. Stakeholders like the customer, you know, the top management, their willingness to take risks. So you need to find this balance between the risks and rewards. You don't want to take so many risks and searching for very high rewards. And you don't want also to avoid taking any risks and ending up with zero rewards. So basically you need to find out the right balance, okay? This includes, of course, conducting risk management planning. We need all the time to start with a plan, right? Risk management plan. And then identifying the risks that might occur in the project, analyzing them, and response planning for those risks. And then when we start, of course, doing the work or executing the work, we need to follow up with implementation and monitoring for those risks. Okay. So what is the risk? First of all, what's the definition of risk? The risk is an uncertain event or condition that if occurs, so it might occur, it might not occur, if occurs, has a positive or negative effect or impact on one or more of the project objectives. Okay, so this is the definition of risk. It's an uncertain event. So it has a probability of occurrence. It might be low probability, 10%, 15%, 20%, or it might be a high probability. This risk has a probability of occurrence of 90%, for instance. Okay, but definitely it's not gonna be 0% nor 100%. Okay, 0% it will never take place. 100% it is there already. It happened already, right? So it's an uncertain event or condition. So basically every risk should have, again, a probability of occurrence. And the other important characteristic is the impact or effect. So for instance, if an uncertain event might take place in the project, but it doesn't have any effect on the project or the project objectives, then you don't consider this a risk, right? To consider it a risk, it should have an effect or impact, regardless whether this impact is positive or negative. Now, this might be a little bit surprising, right? But the formal definition of the PMI includes both. And if the risk has a positive impact, then we call it opportunity. And if it has a negative impact, then we call it a threat. Okay, so basically there are two types of risks, opportunities and threats, and you need to analyze both. Now, someone might ask, why do I need to analyze the opportunities? Because they are opportunities. Why do I need to plan for them or analyze them or qualitatively analyze them or whatever, or plan for the responses? Because it's important as well that you be ready. When an opportunity takes place, you need to have a plan for it in order to exploit this opportunity. If you don't have a plan to exploit the opportunity, you might miss the opportunity, right? So it's equally important to plan for those opportunities as well as for the threats in your project, okay? So for instance, if you are a contractor building some type of construction, then the probability of the raw materials prices to become higher is a threat for you. But the probability of the raw materials prices to become lower is an opportunity for you. And you need to prepare for both, for the opportunity and for the threat. Okay, does that make sense? So this is the definition of risk. Now here are some, again, basic terminologies that you need to understand, okay? The risk trigger, what do we mean by the risk trigger? Or sometimes we call it the warning sign, the trigger condition. This is the event or situation that indicates that a risk is about to occur. Something that we can observe in order to, to help us forecast or anticipate if the risk will occur or is about to occur or not. For instance, you might want to observe the clouds, right, in order to, this is a trigger or a warning sign for the rain. If rain is opportunity for you or is a threat for your project, then the clouds might be a trigger, right? You need to observe the clouds and you need to, this trigger or this warning sign will help you anticipate whether the risk is about to occur or not, okay? So again, you need to identify basically the probability and the impact or effect of each risk, and this includes the opportunities and the threats in the project. Okay. Another important terms, we have the risk tolerance, the risk appetite, and the risk threshold. Now, threshold, we have mentioned threshold several times, right? Okay, you get the explanation here. Now, the risk appetite is the degree of uncertainty that the organization usually, or the individual in the organization, the manager, for instance, are willing to take. So basically, they have appetite for the prices, for oil prices, for instance, between 80 to 90 US dollars. Okay. We are willing to deal, we are willing to work in projects with those prices. This is our risk appetite. And beyond the appetite is always, there is certain, margin, which we call the risk tolerance. So if the prices went a little bit up 90 or a little bit below 80, then we tolerate that, we can endure that. Okay, but if it reaches, for instance, 100, then what? This is the thread. This is the threshold, that beyond it, this is not acceptable, and we need to start applying our risk response plans. We need to start applying the plan that we have prepared to deal with this risk. Okay, so we have no problem in dealing with this range of uncertainty. This is what we call the risk appetite. We can also tolerate a little bit more or less. So this is the risk tolerance. But beyond this, which is the threshold, we cannot tolerate the risk anymore, and we need to implement our risk response plan. Okay, are the terms clear? Okay. Now, risk classification can help you identify risks. We can classify risks using two methods, either by looking at their effect. So we call this the effect-based risk classification. So basically, we classify risks based on their effects, such as time. So risks that affect the time of the project, risks that affect the cost of the project, risks that affect the quality of the project, and risks that affect the scope of the project. This is one way of classifying risks. Another way of classifying risks is based on the source of those risks. So for instance, internal risks, those are the risks that are internal to the project, and external risks like market conditions, political conditions, social conditions. So those are external risks. Technical risks, non-technical risks, management risks, skills risk, for instance, resources risks, and so on, right? So you can classify risks based on their sources, okay? Now, you need to differentiate between project risks and business risks, okay? Business risks are risks that will affect the business as a whole, not only the project itself. And business risks are inherent in any business. Any business has certain risks, because when you decide to start a business, then you took a risk already. This business might succeed, might fail. This is an inherent risk that you are taking, okay? And this also applies for projects. Whenever we decide to launch a project, there's always a possibility of this project to fail or succeed again, okay? So again, risks are inherent in the endeavor, in the business endeavor, and you cannot, take an endeavor without taking risks. The moment that you decide to wake up every morning and go out to your job or to whatever you are doing, then you have decided to take some risks, right? If you don't want to take any risk, you just sit in your bed all the time. Even with that, you might also take some risks, okay? For business risks, we always try to insure them. So you need to contract an insurance company for all kinds of business risks that might exist. Okay. Now, insurance companies can give you, so many types of insurance that you can use on the potential of loss, on the potential of profit, insurance on the inventory, insurance against catastrophic events like fire or earthquakes or whatever. So basically, some risks are insurable while other risks are not insurable. And the golden rule, of course, in business is that you should do insurance. Wherever is possible for insurable risks, you do the insurance. Okay, and insurance is one of the risk response strategies that we will discuss later on. Okay. Again, you get risks from the competition. You might get some legislative risks from the law and the government, monetary risks, operational risks, so many types of risk actually. Again, the moment that you decide to go out of your home, you're taking risks. The moment that you decide to start a business, you are taking risks. The moment that you decide to launch a project, you are taking risks. So it's something that is inherent in your endeavor, especially in the business endeavor, right? And you need to, that's why it's very important to plan for it. Again, whether they are opportunities or threats, okay? How do we identify risks? What are the tools that we can use to identify risks? Those are the common tools to identify risks. Basically, you can do a checklist analysis again. So you go back to previous similar projects and you check the list of risks that we might have faced in previous projects, and you try to identify whether these risks apply to the current project or not. Okay. You might also want to do a root cause analysis, but for risks. So what are the root causes that might cause this risk to take place? What are the root causes of, for instance, of having insufficient fund in our project? Because this is a risk, insufficient fund in the project. Okay, so we try to root cause analyze these risks in order to understand what are the root causes of those risks. We analyze the assumptions and constraints. You might have made certain assumptions in the project that are not completely safe assumptions. So if the assumption is not safe, if you assumed, for instance, that the fund is sufficient in the project, this might be unsafe assumption, and you need to analyze your assumption, whether it's safe or not. If it's not safe, then it's a risk that you need to document in the risk register. You might have assumed that clearances can be obtained on time. You might have assumed that you can use the materials that the company has, while the company, for instance, might have allocated those materials to other projects. Okay, so you might need to go back to the scope statement because we documented this in the scope statement. Okay, you need to all the time know where did we document those information. So assumptions and constraints were documented in details in the scope statement document. So basically, you might want to go back and analyze them and check or identify the risks that might be associated with those assumptions and constraints. Okay. Another tool is the SWOT analysis, and SWOT, as you know, I think, stands for 4 words. Okay, so strength again. We discussed that when we explained the resource management plan, right? But here we are using SWOT as a risk analysis tool. So basically, you try to identify the strengths in the project, the weaknesses in the project, and since you have certain strengths, for instance, you have a very skilled team, then this strength will give you some opportunities, right, to finish the project on time, for instance, or to create a quality product. So what are the opportunities? And the weaknesses will cause some threats. So if I have like a weakness, which is I have a small fund dedicated to the project, this is a weakness. And because of the small fund that has been allocated, we might need to cut quality in the product. So this is a threat, okay? So, and of course, as we mentioned, opportunities and threats are risks. We mentioned, right, that risk can be opportunities or threats. So using the SWOT analysis tool, you can identify the opportunities and threats in your project, okay? Another tool is document analysis. So basically, you review all the documents and the plans and the artifacts that we have created so far and try to identify risks. For instance, you might have decided in the cost management plan to cost your project in Saudi riyals. Now, is this risky? Is the exchange rate between the Saudi riyal and the US dollar fixed or not fixed? What kind of risks we might face based on this decision, and so on. Okay, so you might have decided to use, for instance, the critical path method in developing your project schedule. What kind of risks is there when you decide to schedule your project using the critical path method, and so on. So basically, you go back to the documents that have been developed and you analyze them, looking for any associated risks, okay? You might also want to use some prompt lists, ready lists that help you identify certain risks. For instance, you have this popular prompt list, which is the PESTLE analysis. PESTLE analysis, which stands for political, economy, social, technology, legal, and environmental. PESTLE. Okay, so this is a prompt list that you can use in order to identify risks as well. What are the political risks that might affect my project? What are the economy risks that might affect my project? Prices going up, prices going down. There is a certain market condition. There's a crisis in the market. Social risks. The product that we are working to develop is not socially acceptable, maybe in this part of the world, or in this city, or in this small town, for instance. Technology is the technology that we need to use available, not available, stable, not stable. The legal risks, do we have any legal risks? Someone might, complain against us. Environmental risks, do we have any certain environmental conditions that might affect the project, such as, I don't know, storms, hurricanes, tsunamis, for instance, okay? So basically, this is, again, a prompt list that you can use that will help you identify certain risks as well in the project, or that might affect the project. Of course, you also, you need to consult with experts all the time, using, of course, meetings, experts, stakeholders, and you discuss all of that in order to create a list of identified risks. Now, how many risks you think you can identify in the project? So many risks, right? If you look at it, so many things can go well or go wrong in the project. Concerning, again, the fund, the money, concerning the team, the skills, concerning the material that we will use, concerning the legal conditions, concerning the market conditions, concerning social weather conditions, right? So many things can take place in the project. We might end up identifying hundreds of risks. Is that correct or not? You might end up identifying with the team, of course, hundreds of risks. Are we able and capable of planning and analyzing all of these risks? The answer is, of course, not. No, you cannot. No one can. You will never have enough time and resources to analyze all the project risks and to plan for them. So what do you do in this case if you don't have enough time and resources to plan for or to analyze those risks? What do? You basically focus on the most important risks, right? We go again by priority. We focus on the list of prioritized risks, correct? And how do we do that? I think you need like 10 minutes break. Or shall we continue on until we finish? Because we're very close to 9:30. What do you think? Yeah, let's continue on. Okay, so basically, using those tools that we mentioned, you might have identified hundreds of risks. Okay, but you will focus on only the most important risks. How do we do that? We will explain later on. Now, after you have identified those risks, you start documenting them. And where do we document those risks? We document those risks in a document that we call the risk register. So this is basically the main document that we will use for planning and for tracking risks as well throughout the project. Now, this is a template of the risk register. As you see here, you have the risk description. What is the event that might occur? The impact. If this event occurs, then what is the impact on the project, on the quality, on the scope, on the cost, on the time? And again, we have two main characteristics that we need to estimate, which is the probability and the impact. We might use a level, so a level of impact, a level of probability, for instance, a scale from 1 to 5, where 5 is the most and 1 is the least. So basically, if the impact level is 3, then it's high impact. 5 is extremely high. 1 is very low, for instance, right? And the same for probability. You might use a scale from 1 to 5, where 5 is very probable, while 1 is very improbable, okay? And based on the level of impact and level of probability, you can identify the priority. This is what I have mentioned, right? You need to focus on the most important risks, on the prioritized risks. And how do you identify the priority? By simply multiplying the impact level by the probability level. So 3 multiplied by 5 equals, for instance, 15. Or you can use this matrix that we call the probability impact matrix. So probability have, again, a scale of 5, and impact have a scale from 1 to 5. And of course, the most important risk is when you have a probability of 5 and impact of 5, which is here, right? So 5 by 5 equals 25. While the least important risks are or have the probability of 1 and the impact of 1, which is here. 1 by 1 is 1. Now, of course, notice, why did we choose multiplying those? Because if the probability is 0, or if the impact is 0, then you get a priority of 0, right? Because it doesn't have a probability of occurrence, or it doesn't have an impact, so it's not considered even risks, right? So for this reason, either you use this rule, which is multiplying, or you can use this matrix, and you can categorize those risks based on their priority now. So you have now the green, so you have now the red zone, the orange zone, so they are less priority, and then the yellow zone for, again, less priority, and the green zone. Now, the green zone is basically the risks that you don't need to plan for or to analyze, because they are, the low priority risks. What do we do with the low priority risks? do we overlook them completely? No, we also document them, but we document them not in the risk register. We document them in a document that we call a watch list. So these are risks that we will watch, we'll keep watching, we'll keep monitoring. We will not analyze them, we will not plan for them as for now, but we will keep monitoring them. Why should we continue monitoring them? Because their probability may change over time, or their impact may change over time as well. So they might be not important at a certain point, but after a week or after a month or after a certain amount of time, their probability change or their impact change, and they become what? Important risks that we need to plan for, and we need to analyze, and we need to plan responses for. Okay, so for that reason, we will keep them on a watch list, and we will revisit them every now and then to make sure that they are still low priority risks and no need for further action. Okay, what we will be focusing on is, of course, the most important risks, the priority risks, which again are probably the red and the orange zone. Okay, does that make sense? Any questions so far? Okay, so this is basically what we call the qualitative risk analysis. Qualitative risk analysis is a technique that we use to determine the priority of the risk by looking at the probability and the impact, and multiplying the probability by the impact will give us the risk exposure. We call it the risk exposure or priority, or sometimes also we call it severity of the risk. Severity. So basically severity or exposure represent the priority of those risks, and we get them by multiplying the probability by the impact. Okay, and by this we have, or we prioritize our risks, and we have a list of prioritized risks in the risk register. So basically what you need to do after doing the qualitative risk analysis is that you need to go back to the risk register. This is what we usually do, and relist the risks based on their priority. So the red risks first, and then the orange risks, and then the yellow risks, and of course the green risks will not be included in the again in the risk register. We include them in the watch list. Okay, now the size of the matrix is up to you and your team to design, because you can use a simple, like we have seen, only 5 from 1 to 5 scale, or you might want to use a more detailed matrix, like here they use a scale from 1 to 10 for probability and 1 to 10 for the impact. And if you use scale from 1 to 10, you get this big matrix, and you can again select which, or classify your risks based on their importance to red risks, or to the red zone, the yellow zone, the green zone, and decide what are the risks that you need to analyze further or to plan responses for. Okay, so again, it's up to you and the team to decide on how many levels of probability and how many levels of impact that you want to use in your project in order to qualitatively analyze your risks. Okay, so here are some guidelines for prioritizing, for identifying and prioritizing risks. Perform structured review. So structured review of the documentation. So again, it's important to go back and analyze and review all the documents that we have developed so far, and try to identify as much risks as possible by reviewing those documents. And you also want to try to identify as well the triggers that you need to monitor in order to, to monitor those risks and their probability of occurrence. Be consistent, so you do this on all or on every part of the project. You go and analyze every work package, for instance, and you also look for special circumstances, like, for instance, you might have a certain special market crisis or certain political crisis in the region, so you need also to look out for the special circumstances as well. You consult historical information, you go back to the previous projects and use the records, the lessons learned, in order to identify risks as well that might take place in your project. And you categorize and group the risks in common areas where you want to focus more, the red zones, the green zones, the yellow zones, and so on. And then you document all of that in the risk register, which is again the main document that we will use to plan for, to analyze, to identify, to track the risks throughout the project. Okay, let's stop here now. In the next lecture, we will continue to quantitative risk analysis, which is also a very important thing that we need to understand. So let's stop here now and postpone this until the next lecture. Any question, ladies and gentlemen? Hope that everything is clear to you and that you're still having the chance to review all the lectures. That's very important. Again, I need to emphasize on this. It's very important to review to help you, compile and digest all of these information. Okay, so see you inshallah next Thursday. I'm wishing you a very pleasant evening and good night. Thank you all.